guys, you're back with another video of Mastercam 2022, and in this video I will pursue with the same part that we left, the door handle, and show you how to complete the holes by making the drills in this one, and also by removing the excess material that we left last time, which was 50 thou in the parameters, as we can go and see in the model geometry, which is 50 thou the wall stock, and also on the floor. So let's get started. And before I get started, I would like to apologize for too long of a delay for most of the videos because of my work and other conditions that I have right now, because of which I'm not that regular. But at the same time, I have some other stuff going on, which in future I might be posting on YouTube. So stay tuned for that. And also, if you guys have any concern, just send your text in comments. And thank you so much till now. We are almost close to 500 subs, so thanks a lot for that, and I appreciate you guys for being together. So in this part, we remember that we had some material left, which is like 50 thou we left intentionally, so we need to get rid of that first. So what we can do is we can either use contour, or let's try some other variation if possible. So in this case, last time we used 3D high-speed area roughing, which was something unique that we used, which was a little bit different from what we usually use, and we found out that it was a good choice instead of just using standard area roughing. I'm just trying to figure out which exact area, or we can also use pocket if we want, because we already have a contour to work inside with. And then for finishing, let's see, I'm not sure, it's been a while. Alright, levels, wireframe, not wireframe, salute, yeah, this might work. Wireframe doesn't work. Wireframe, I'm looking for wireframe. Oh, it's just selecting the solid, eh? Okay, no problem. Clear selection. I think it's just going to let me select. Alright, no worries. Dynamic mill, we'll go with contour. Let's go with that. So now we have two different choices again. Just like we had 3D high speed, which was basically area roughing, in this case we can choose which one to pursue. So we have area roughing, we have multi-surface pocket. I mean, it really doesn't matter which tool path you use, it's just like the way you are going to use depends on that. You can also use contour, you can also use pocket, you can also use dynamic milling, all up to the same thing. Or what I can do is simply copy, right click, copy and paste the same. Just make sure the red arrow is below that operation, and Control V. I don't know why it doesn't show up. Paste is not highlighted most of the time. I go to the parameters. I can simply make wall on stock 0 and floor stock equals to 0 as well. There we go. Toolpath control. Everything else is going to be the same. I'm not going to change anything else. And steep angle, maximum depth looks fine. Everything else I'm just going to increase. So in this case, because it's the finishing one, so what I can do is I can toggle between the cut tolerances to be maximum. So cut tolerance, it depends on how much tolerance you want to keep. Is right now is, oh, it's fifth, it's not even 5/10. I thought it was 5/10. So whatever the cut tolerances are, so let's say I'm going to keep 5/10, let's say, and go for that. and make sure you have all of them checked, and plain, coolant on, everything else to be fine. That's fine. It's going to take some time because it's a heavy operation unlike other ones. And there you go. So it showed up. Don't forget to save because Mastercam crashes a lot. So we are already done with area roughing. Yes, I do understand it's called area roughing, but eventually we are doing the same thing, so it hardly matters, right? So the next step would be to make these holes right here. So that's very important. So before I pursue anything else, I'm going to select all of them and hide it so that it becomes visible for me to make sure what exactly I'm working on. So right now I know that these are the holes that I have to dig, and I'm already done with all the machining of most of the part. To make these holes, so now I'll go for drilling and select the diameter. Just make sure to select the inner core. If you're not sure, just select the circle itself, the center of it, both the centers. Just make sure the dots are in the center, and it gives you the diameter automatically right here. If you're not sure, you can always verify by right clicking and analyze entities. So what the diameter is 0.0906, which is like 90,180, close to 180. Diameter is 0.18. So I mean, or if I say analyze entities of this circle, you can say it's 0.1766, which is close to the second arc, which is right. So now we can use these two drills if we have that particular diameter. I'm not even sure if we do, but let's try. So one of the drill is 0.16 something, and the other one is slightly bigger of a hole. So in order to do that, we need to find the right tool. So 0.16. Either we can use an end mill if the size is not available, because it's a very random size that we are going to work with. 0.16 something something, right? 167 not equal, between, let's see, 0.15 to 0.18, let's say. Alrighty, so we have different type of, alright, there is a list. I'm just going to use my snipping app. I'm just going to snip it quickly just to make sure that these are drills that I have available. I'm going to close it for now. I'm just going to analyze entities. Alrighty, so I have 0.1766. So 0.1766. So we have 0.177, which is the closest one to this number 16 drill. So 100 is the one that we might be using for this hole, 0.1766. And then we have the other one, which would be 0.1766 as well. Interesting. Wait a sec, let me select differently. 0.1766, again the same one, number 10, number 16 drill, my bad. 100 to number 100, number 16 drill. 0.1766, yeah, that's the closest one. So we are going to use number 16 drill just for the fact that I'm pretty sure we started with a different conversation. by when I designed the part. It might be in metric, so that's why I might have designed in such a way. But yeah, number 16 drill is the one that sounds to me the best, so I will be using that. Or we can do it in two different ways. Either if you don't have number 16 drill, you can also use um, 1/8 end mill and just make a simple pocket and two holes out of that if you're not sure about that concern. If you don't have the access to the right size of drill, just I would say just use an end mill. It could be a bull or a ball. Well, I would recommend it's a bull because if you don't want a rad at the bottom, then yes, bull would be your first preference, and it can also plunge a little bit versus the flat one that won't be able to plunge that much. So two options, either number 16 drill if you have it in your library, or you use 1/8 ball. So the ball will help you to actually plunge, and it will have a little bit of rad depending on which one you choose, instead of having a bull which is completely round with respect to the end mill. So you choose bull 1/8 and that would be good. Alright, or you choose a drill and do the same thing, make holes, no problem. So now we can go to drill. Make sure to choose in the middle always. If not sure, go to the top. Make sure to choose in the middle. There we go, number 1 and number 2. There we go. You can verify in the isometric. Yeah, looks good. Select it on the top. On 173, 173, perfect. Good enough. Go to tools. Oh, number 17. Okay, it's 173. That's a perfect diameter right there. Number 17 it is, because when I went on the top view, it gave me the right dimensions. So 0.173 is what we are looking for. Feed rate for the drills, considering it to be aluminum part, we have around 30, as far as I remember, 3000, because we are trying to, so yeah. So sometimes if you're not sure, like 5 to 30, okay, this might be confusing. You can always check on Google if you want to. I mean, just go for it, that how to use drill, aluminum feed and speed for drills, aluminum cutting, if you're not sure. So it says, alrighty, it says feed equals to 1 thou per revolution for 1/16th of the drill diameter, plus or minus 1 thou on total. SFM, 80 SFM. Alright, that makes sense. But if I really want to precisely check how much is it, there must be some image or a standard chart that they use. Yeah, see, right here. Okay, tool or stock diameter. Alrighty, diameter is 0.125. So they're given us the RPMs and all, like different material. Mild steel, aluminum is around 8000. Okay, and you can see the smaller the diameter, the higher the RPM tends to be, because as the diameter gets bigger and bigger, it's better to keep the RPM less. So feed rate for drill, So you can always see that's the scenario. And just a sec, this is around 10.01 millimeter, 0.05 millimeter. Not sure, then find an inch. Alrighty. Perfect. So we are just going to pursue with the same, around 5, 3000. Feed per tooth looks fine. Pectoral looks good. Yeah, Lincoln parameters is something that we need to work with. And we also need to make sure about few certain things. That one of them is clearance. If you're not sure, just click on it. Just verify, because we know that our part is below that, so we don't even need to select. Retract, I can keep 0.25. I don't need to go that high. Top of stocks, we already know that we have already plunged down to this particular depth, and I can use this as my top of stock, or I can just keep it like -1 for my personal concerns, and depth to be all the way down right here, and add some depth to it. So I'm going to go, or I will just add this particular depth to the tip compensation. Tip compensation, breakthrough amount, I'm going to keep 250 thou. Then everything else, plain, stop, looks good. Coolant on, there we go. Perfect, it went all through, looks good, not bad at all. So now I'm going to select and activate all these operations. So far it looks good. I'm going to save it, and similarly I can do the other things as well. Again, I'm going to hide it. I just like to visualize before I pursue, and if something I might be missing, that that is also possible. So what else, what else left? Drill. We also have chamfers. If you see right here, I never use the chamfer drill. Interesting. It would be an interesting one. Right here I go to the top view, I see this one, and I see this one as well. Alrighty, 0.34. Okay, isometric on top. Alright, isometric. Okay, 0.3401. 0.3401. So let's see. It could be chamfer. It should be a chamfer. Chamfer, spot, center, threadmill, reamer, chamfer. Need to find chamfer mill right here. This radius chamfer mill. 0.34 equals to or less than, let's see, 0.35. I know it's 0.34 something something. Okay, 1/4. Perfect. Sounds good. Looks good. Sounds good. Just going to keep it 25, because remember, in the beginning I made sure that all the stock parameters and tool settings are from material, so they are close enough to what they should be. So plunge rate around 15 is fine, even 10 to 10, 20, anything. So yes, honestly I've never used this, so let's see what exactly the options are. So it says width and depth. Alright, we can only use one of them. Which one do we need to use? Okay, we can pursue depth. Let's see. So I know I have to increase the depth, or how much do I want to cut? 12. Perfect. Let's see. I'm going to keep 10,000. I don't know, I might be wrong. Linking parameter, one or more tool entities cannot be chamfered with the selected tool. Alrighty. Point oh, the tool is a little too big. Okay, need to use a little smaller tool, less than 0.25. Let's go. None. Wow. Ignore. Just any chamfer mill. Ooh, it's going to be a close one though. Because 0.25 is not, I cannot make it because it says that it's very small. So maybe I need to make a smaller chamfer mill. Chamfer mill outer diameter needs to be smaller than 0.25, so I'm going to keep 0.125. Overall length is fine, cutting length is fine. Tip diameter. So 0.1 looks fine, yeah. Next. Tool number 5, finish. Yeah, I'm okay. Let's see if I use this one. That makes any difference though. Linking parameter, absolute values. I'm going to select right here somewhere, or -1 looks fine. Retract, I don't even need to, that's fine, but still positive 0.1 is fine, more than enough. Top of stock, where I want to use the chamfer, it's right here. I don't need to, that's fine. Safety planes, top, coolant on. Let's see. One or more entity with a selected tool is not operational. Yes, I want to keep it. Chamfer drill. 0.005. Alright guys, it's very interesting. Diameter 0.125. It's very interesting that I never used this. Well, anyways, I would say for this video we are just going to pursue till here. I'll figure out how to get that thing done. In next video I'll show you how to make that work. So for now we have pursued till here. So stay tuned for the upcoming videos and take it easy. Bye.